Hello everyone, welcome back to another video of computer vision. So in this video, I'm going to talk about how to use the image annotator for your images for the extra credits. So if you go to the GitHub link Professor provided and then git clone in the repo, and then if you go inside the folder of ISD annotator, you will see the folder structure like this. So that is the step one. And step two is add the image folder to the directory containing the image annotator folder. So I think the base directory is this one. So, and the image annotator is this one. So you have three Python file here. And the test images is the image folder one, I assume. And then you have some other files here. So that is step two to make sure you can copy your images here, in a folder here. And then step three is update image folder variable assignment in annotator driver. So let's go inside this image folder. Yeah, I think you can change the name of this to your image folder, but I will leave it as default test images for now. And step four is execute annotator driver. So let's try. So I have some tested runs before, which means let me show you the current directory. So you can change directory to the ISD annotator to this base directory first, and then use Python or Python 3, and then annotator, and then the driver. Yeah, and then the GUI will appear like this. So the left one is the original image. On the right is the processed image. That is step four. And step five, annotate the image. So left click is add an annotation and right click remove a single annotation. So let's try that. Oh, this is. Okay, so let's leave the parameters as default for now. So the first point should be a lit region, and then the second one should be a shadow region. So let's first try here. It's the lit region, and then the shadow region here. Okay. And then maybe make one more annotation here and here. Yeah, so I think the annotation script lets you pick lit or dark pairs and control the size of the area around the click used to compute the illumination ratio. It also shows you the result of using the illumination ratio to generate a chromaticity image. A well-selected lit or dark pair should make a chromaticity image that is as shadow-free as possible. So you can see we have shadows here on the original image, but some kind of lighter shadow on the processed image. And I wonder what are those parameters mean, because this is also the first few times that I use this program. So yeah, I think the patch size is how many pixels around this point, like used to calculate. Yeah, and then the patch size will modify the computation of the ISD and often improves performance. Let's try to make this value larger. I don't see a significant improvement Probably because it is pretty average in the area that I already picked. How about the anchor point? You will make it darker and brighter. I think the original value is good for this one. Also, we can make not only two pairs if you want to add like, okay, another one here, another one here maybe to make the result better. So step 6 is assign the image to a destination folder based on observed results with keystrokes. So for example, we can hit H key to store the excellent results. Let's try to do it by pressing H. Okay. And then the next picture will be shown. So let's do a few more examples to play with the parameters here to see the difference. So if I click on here, the lit region, and then the shadow, the lit, shadow, the lit, shadow, the maybe the grass. Let's try. Okay. Yeah. And shadow, shadow. Also, let me try to right click to unselect those points. Okay. Let's try again maybe. Mm, Touch size. Okay. I think this is good enough because you can see the shadows of the tree and the grass. But here, if you see the grass, there's no shadow of the tree, but there are still some shadows from the stone remains. Let's save this one. Okay. So the next one is, let's try to do this, and then maybe here. Okay. One more. Okay. And then the anchor points. Yeah. Also, this one is showing no shadow on the grass, which we want to save this one. Quickly do another view. And, this one. Um, Let me see if there's are any other choices that we can use. Okay, so T is terrible results, the input image of low quality. So I'm not saying this image is low quality, but if you really don't want to save this one, we can press T and yeah, let's try. And then yeah, it works. And let's try this one. Hmm. Yeah, the result of this picture is really good. So you can see the chairs and table like even inside the glasses. And then there are no shadows on the tables and chairs at all. Try to do this. And don't forget to pick at least two pair of lit and shadow regions. Yeah, I think we have already done enough examples here. So what is the, yeah, if you click on Q, it will quit the program. So the results will be at image folder. Okay. So the result will be stored inside your image folder. So for the current folder, and I have processed images, and if you see the high quality folder, these are the images that we annotated. Yeah. Also this one. Image arrow SD maps. Low quality. I don't have the bad image. Okay. So you remember we put one of the image in the bad images. So also if you open the CSV file, don't know why this one is empty, but if you go to the XML, yeah, so here you can see all the information of the annotation we did. So let me just double check for the uh, 58, 59, 61, 65, and 75. Yeah, the file name seems correct. And you can also see the annotation here you have done. Yeah. So one suggestion is you can try with like 3 or 5 images and see if the process is done correctly, and then you can start doing more images. Yeah. So that's all for this video, I guess. If you have any other questions, please send me an email or post the question on the PR, and we'll try to answer it. Thank you.